A SIGMET is a vital, concise report crafted in abbreviated plain language that flags specific, hazardous in-flight weather phenomena, essential information for keeping every aircraft safe. These critical updates are issued by designated meteorological watch offices, MWOs, which hold the responsibility for overseeing specific flight information regions, or FARs. While standard SIGMETs cover subsonic flight, keep an eye out for SIGMET SST, those specialized alerts specifically tailored for aircraft operating during transonic or supersonic phases. SIGMETs are highly structured, utilizing a precise system of abbreviated plain language to ensure clarity and speed. You'll recognize many of these abbreviations from our deep dive into low-level significant weather charts, though you might spot a few new ones today. Take a look at the full list displayed here. Feel free to pause and spend a few minutes getting familiar with these codes. Ready to see how a SIGMET comes to life? Let's break down the individual components of a sample message to see how they're structured. We start with the location indicator for the Air Traffic Services unit serving the FIR. In our example, that's Yankee Uniform Charlie Charlie. Next, you'll see the word SIGMET itself, which serves as our clear message identifier. Right after the identifier, we find a sequence number. In this case, our sequence number is 5. This number is a handy tracker, representing the total count of SIGMET messages issued for that specific FIR since 0001 UTC that day. Pro tip: keep in mind that these sequence numbers can sometimes be a combination of letters and digits. Next up are the date and time groups, which clearly define the period of validity for the SIGMET in UTC. In our sample, the message is active on the 22nd, starting at 12:15 UTC and running until 1600 UTC. The final set of characters on the first line provides the location indicator for the MWO that originated the report. We then add a hyphen to create a clean break between the preamble and the incoming weather details. For this example, we are looking at Yankee Uniform Delta Oscar followed by a hyphen. And just like that, we've wrapped up the first line of our SIGMET. Moving to the second line, we lead off with the name of the FIR or control area covered by this alert. For our example, we'll be working with the fictitious Amswell FIR. Next, we identify the specific meteorological phenomenon that triggered the SIGMET issuance. We pull this directly from the standard table of abbreviations we covered earlier in the lesson. In this instance, we are dealing with severe turbulence. Following the phenomenon, we specify if it's currently observed and continuing, marked by the abbreviation OBS, or if it's a forecast, marked as FCST. When applicable, we also include the specific observation time in UTC. Using our example, OBS at 12:10 confirms that the severe turbulence was officially observed at 12:10 UTC. Moving right along, the next section defines the precise location and altitude of the phenomenon. Whenever possible, we reference latitude and longitude or internationally recognized geographical landmarks. Common examples include a forecast top at FL 390, south of 54 degrees north, or over the Shinnichka Oceanic at FL 250. In our case, we use EASA at FL to 50, letting us know the severe turbulence was observed at 12:10 UTC over FIR EASA at flight level 250. To track the movement, we use one of the 8 cardinal compass points. The speed is reported in kilometers per hour, knots, or noted as stationary. We've specified MOVE 40 kilometers per hour, meaning our severe turbulence is currently drifting east at 40 kilometers per hour. Finally, we indicate any change in intensity using the standard abbreviations for intensifying, weakening, or no change. For this example, we've selected weakening. Now, let's see how it all fits together. Our fictitious SIGMET identifies the 5th message issued for the YAC flight information region. It was released by the UDO Meteorological Watch Office, effective from 0001 UTC and valid from 12:15 UTC until 1600 UTC on the 22nd. To wrap it up, severe turbulence is tracking east at 40 km per hour and is currently weakening in intensity. When SIGMETs for volcanic ash clouds and tropical cyclones are issued, keep an eye out for an important, additional line of text. This extra line provides a handy outlook forecast that extends beyond the initial period of validity mentioned earlier in the message. You will find the projected trajectory of the volcanic ash cloud or the predicted coordinates of the tropical cyclone center, depending on the hazard. It is vital to get comfortable with the specific structure and nomenclature used in all SIGMET messages. Mastering the interpretation of SIGMETs is a key piece of the puzzle for successful flight planning.